there are three main applications of a potentiometer. The first one is comparison of EMFs of two cells. As you can see the circuit diagram, the parent circuit remains same, just the difference is in the secondary circuit. In the secondary circuit, here we have two EMFs, E1 and E2, and there is a two-way switch. That means if S is connected to 1, then E1 is connected with the circuit, and if S is connected with 2, then E2 is connected with the circuit. This is a two-way switch, and let us see now what happens. There are some steps. First of all, you should check whether the connections are correct or not. And as per the heading of the topic, we will compare these two EMFs, that whether they are greater than, less than, or equal to each other. We won't get an exact value, but we can say if E1 is greater than E2 or E1 is less than E2. So first, in order to check the correctness of the equation, first connect the switch S with 1. Then, as we did in a meter bridge, keep the jockey at A, mark the direction of deflection of the galvanometer. Now move the jockey to B, and now mark the direction of deflection of the galvanometer. If both the directions are opposite to each other or different from each other, then in that case the correct connection is correct. Similarly, now connect switch S2 and once again check the same procedure. If the directions of deflection of galvanometer are different, then the connections are correct. Otherwise, you have to see the connections again. Now, if you are satisfied with the connection, connect the switch S with 1 so that E1 EMF is at play now. Now move the jockey slowly from A to B, and wherever the galvanometer shows 0 deflection, stop it there. That means potential difference of AJ is equal to K into L1. How did we get here? By using the working principle, that is, potential difference across the part of a uniform wire is directly proportional to its length. So potential VAJ will become K times L1. Now, as no current flows in the circuit or no current flows through the galvanometer, we can say that VAJ is equal to E1. So no current flows in that part. That implies E1 is equal to VAJ is equal to KL1. Similarly, now if we close the switch S2 and once again move the jockey from A to B, and suppose this time we get the balance point or 0 point at J dash, then E2 will be VAJ dash, that is K into L2. E2 will be VAJ dash, which is equal to K L2. Now these are our two equations. Let us divide them. So E1 by E2 will be KL1 by KL2. If you cancel both the K's, you will get an equation E1 by E2 is equal to L1 by L2. From this condition, we can get to know whether E1 is greater than E2 or less than, or both are equal, depending on the ratio L1 by L2. Alright. Okay, so let us stop here today. We will proceed to the next part in the next video. Thank you.